Good afternoon once again. After an hour-long break, and after a longer break, the last presentation by Hill Corporation here was in 2019. Since then, we've been going through quite a lot of positive changes, and I would like to share with you everything about that. In terms of what was happening in Hill Corporation in 2010, the company started lubricant production plant blending of 70 KT of design capacity using FMC Technologies as the licensor. In 2018, Hill Corporation launched the site which makes greases with a capacity of 1.5 KT and waste oil re-refining with licensed by Fluid Solutions of Germany with a capacity of 28 KT of feedstock. The complex is located at Shymkent in Kazakhstan. In 2020, we registered Hill Group in Lithuania, and we started design works on designing and building the facility to blend lubricants and do re-refining to make Group 2 base oils. Base oils production using the re-refining technology was not a random choice. There were prerequisites to do that, as opposed to Russia, Belarus, and Uzbekistan, where for a long time there used to be lubricant production plants, and those nations are making base oils on their own. In Kazakhstan, up until now, up until recently, they haven't had a lubricant plant to make base oils. On the one hand, this is a valuable feedstock. On the other hand, used lubricants are wastes. Number two, the lubricant consumer market in Kazakhstan is around 120, 130 KT per year. Most waste oils would be burned or end up in water or soil, producing a negative environmental footprint that is 50 to 60,000 KT of wastes of the type. In view of the worldwide trends, from the point of view of environmental protection, we have seen some legislative changes in Kazakhstan, which made producers of lubricants pay attention to this technology of re-refining for making base. First of all, in 2015, the Operator of Extended Producer Responsibility, LLP, the ERP operator, was established to deploy a unified system of integrated waste management of products and goods. And that includes not only used lubricants, but also used vehicles and tires. And the utilization fee was introduced, which did have an impact on the cost of lubricants. In 2019, the national standard of the Republic of Kazakhstan on wastes used lubricants came into force, and it also contains requirements for collection, storage, transportation, receipt, and reprocessing. Under the standard, valuable raw materials, waste lubricants, should be sent for reprocessing to obtain base oils. Thus, we reduce the amount of burnt waste oils, which are detrimental to the environment, and companies are now obliged to collect and to transport used lubricants to specialized organizations. And in 2021, at the moment, they are developing the draft environmental standard, which would introduce still higher bar of requirements to waste oils to prevent the burning of those or disposal in water or soil. So two areas, more stringent norms of environmental side and invaluability of homemade base oils made Hill Corporation to arrange re-refining technology production of base oils in Kazakhstan. As the licensor, Fluid Solutions of Germany was chosen, and in terms of the key units, first of all, we collect waste oils, we sort them out, we do the quality control, then we use filtration and hydrogenation to get rid of mechanical impurities in water. Then it makes it into the psychoplasmic tube reactor, and in the presence of potassium hydroxide, we extract high viscosity fuel fraction and high viscosity residue. Then base oils, which we end up with, go to clay refining, and then we end up with a commercial product, which is base oil. More often than not, we hear the question as to the yield, and those are the yields covering about half year of operations. About 70% of what we get is the key product, base oil, and we have quite a lot of high viscosity residue, up to 20%. Up to 20%. Also in the slide, you can see a snapshot of our regen facility. That is the outer part of the cycloplasmic tube reactor. This is the degas column. I will not go into details of the process because the next speaker is the representative of Fluid Solutions, and he will give you all the details about that technology and answer the questions. We, as manufacturers of lubricants, were first and foremost interested in yields and, of course, quality of outputted products, key products, and byproducts, which we end up with as the result of using this process. To have an impression of the quality of feedstock, intermediate products, and re-refined products, in one of the pilot runs in August of 2020, what we did is that we took at every phase, after dehydrogenation and after the reactor and after clay treatment, we took samples and we looked into physical and chemical parameters of those. In the slide, in the tabular form, you can see those parameters. As soon as dehydrogenation, we get rid of water and some light fractions because your flash point is going up. After we introduce the hydroxide in the cycloplasmic tube reactor, we eliminate the base number, and all the way to the phase of clay treatment, the changes lead to improved color from 64 to 2, which indirectly tells us that we get rid of polycyclics, aromatics, and resin nature compounds which could have been there, thus attributing color to the base. Also, as you can see, sulfur is quite low, about 2.2%, quite high viscosity index. That has to do with the fact that this technology allows you to process lubricants such as motors oils, transmission oils, industrial oils, mineral and synthetic based. So in other words, the technology is very versatile and omnivorous. In the waste oils, as we all know, we find quite a lot of products generated through waste and tear and aging of metals. This is how this technology does in terms of eliminating all those impurities. At every phase, we can see that there are quite a lot of various chemical elements. Now, first and foremost, we strip those out in the cyclic plasmic tube reactor. We get rid of almost all of them, apart from a couple which react further. And after clade treatment in the resulting base oils, we have no unwanted chemical elements whatsoever. This is just an example from one of the pilot runs. In every particular batch, we investigate into those parameters and we achieve the targets which I indicated and presented in the previous slides. We do that on a regular basis, and to fine-tune the process, we look at about 4 more parameters which are not reflected upon here. Going back to the API classification, that is standard 1509, based on that standard and Annex E, base oils of category 1 could be obtained via various processes, solvent treatment, hydro processes, including regeneration technology. In terms of specific requirements, it contains none, apart from the requirement that the technology should be a multi-phase, and the base oil, which is the result of the process, should be fully stripped of all the impurities. Those are the key physical and chemical parameters and changes in the content of elements in the resulting product. But perhaps we missed something. So to make sure we do a quality job or not very high quality job, we resorted and we still resort to certain investigations trying to bring in regeneration, regenerated hill-based oils in various groups, such as greases, industrial oils, and motor oils. The scope of work is quite large. We continue on that path, and the key emphasis, apart from key physical and chemical processes, is made on anti-oxidation properties, anti-corrosion properties, and having in mind the large scope of this undertaking, I would like to throw at you a few examples of commercial products which use regenerated base oils, and somewhere it is comparison with based oils from traditional sources or international standards. One is our compressor oil, to see whether, to what extent it is possible to use regen material in compressor oils. We prepared several samples of VG32, petroleum-based compressor oil samples, and re-refined oils from various batches of August of 2020, which I mentioned in the previous slides, the one of December of 2020, the batch also of March of 2020. As the control sample, we took a base oil made by a Russian company, and we used the same package to make commercial compressor oils. I will not be speaking about physical and chemical processes, only ghost-based oxidation. First of all, in terms of changing of kinematic viscosity and the amount of residue, compressor oil which contains regen material is not inferior, or in some batches even superior to the quality of compressor oils made with traditional solvent technology. And number two, as we can see, from batch to batch, thermal oxidation stability of commercial oils would be a bit different, August, December, and March. Why? Waste lubricants are not homogeneous, and the composition could be different from batch to batch. Therefore, it is important for the producer to do the right job of sorting activities, and based on the outcome of input control of quality, one should fine-tune the technology in terms of temperature regime, consumption of alkali, etc. If one does that, the quality of base oils proves to be quite high, and this process enables us to make a Group 1 base which is not inferior to the traditional ones. To put it honestly, once again, to emphasize, this is very much dependent on the regimes opted for in the process of regeneration of used lubricants. One might know that one of the most critical units where lubricants are used are internal combustion engines, that is, motor oils. So for us, it was paramount to see how our regen material might perform in motor oils, and we still continue that research, investigating into opportunities of making our regenerated material in the specs of SAE 15W40 and API C14. We partially brought that in the formulation. As you can see here, is 71% of regenerated based oils and about 16% of SN600. This is the base of Group 1 in the traditional technology. Those are some of the results we received. This kind of product features quite high thermal oxidation stability, about 102 minutes, versus the required not less than 60. Lubricants on the traditional oil basis have it about 120 minutes, so our results are quite good. We also looked at corrosion resistance properties. Also, the results were quite good. I could have basically ended this presentation with that and our activities as well. We did experiment on the quality of base oils. We did investigate into the potential of using it in various groups of lubricants. But I would rather go further, and that is why. As I demonstrated in the initial slides, there is quite a lot of byproducts we end up with during the generation. One is high viscosity residue, and at the previous conference, I had the question, what do we do with that? Many producers which are thinking about making base oils via regen ask the question, what do we do with 10 to 20% of high viscosity residue? How do we make our projects greener? How do we make them more economically efficient? Within the scope of our configuration, we did not think about any further steps with HVR. We considered various options. One of the options we did implement is to use HVR for the so-called compounds, specialty compounds, which are used for road construction purposes, for roofing purposes. And in 2021, we amended our configuration with additional equipment and came up with a number of formulations which are using HVR to make specialty compounds. And this is the first batch of the compound which we made in May of 2021 during those May holidays we had. And this is how this mastic is used for road repairs in Turkmenistan. That's the snapshot taken in May. This is what we do, utilizing our HVR for the manufacturing of mastics. So this is how we improve the environmental awareness and the greenliness of the project. And that means to say that 70% of regen is used as constituent compounds of other commercially demanded products, whether in part or in full. The remaining 20% of HVR, as you can see, is also used for making those commercial products, such as mastics. And we end up with a small amount of fuel, but we are also pushing forward with it too, so that it would be brought in, this fuel fraction we end up with, into some pool for making commercial fuel products as a component. So now a few words about the sustainability of such projects. From year to year, we pay more and more attention to issues of environmental protection, and Kazakhstan is not an exception. So environmental issues rank high in the government agenda. And in our project in Lithuania, we appreciate that environmental issues associated with regen and recycling, for instance, of used lubricants, is also very important. As the previous speaker mentioned, environmental issues are key concerns now. And those are the results based on the information available for Europe in terms of regeneration of used lubricants. Many plants say that regen units are associated with negative CO2 emissions. Number two, one can reuse lubricants. Some producers, existing plants, say that they can do this within 3 to 4 cycles. That is subsequent to regeneration and further use. And number three, the relevant regulations in Europe and sovereign regulations are getting more and more stringent. For Kazakhstan, this is STRK 3129. And wrapping up, those are my key conclusions. And you can read through that. I hope that that was useful for you and did answer a number of the questions which you might have had regarding the regen technology of used lubricants. And our next speaker, Boris Nigrovsky of Fluid Solutions, will give you still more details about this process and the experience of using